Hi, Viper chemistry students. Let's take a look at balancing equations here. I've got a couple charts here, a before and after, and then a problem to solve up here to balance. Okay. Let's take a look then. How do you develop a strategy to solve this problem? We have to make sure that the atoms on the reactant side here are equal to the products on the other side of the arrow. Um, the way this would read would be CH4 plus O2 yields carbon dioxide, CO2, and water, H2O. All right, but we have to balance that equation. So let's start with how many we have of each. So we have carbon, we have hydrogen, and we have oxygen. How many carbons do we have? Looks like we're 1-to-1 on the carbons. This is before the reaction. In hydrogens, we have 4, and we have 2. And then oxygens, we have 2, and we have 3. Now that 3 kind of stands out because that tells us on the product side over here, we have sort of an odd number of oxygens, and on the reactant side, we have an even number. So that might be a place to start. So you just kind of have to, as you do these and you practice these, you kind of have to develop your own strategies, but that's the way I would start. So I want to make this an even number. So if I go over here and put a 2 here, now that gives me an even number. So I would say with my oxygens here, then I would now have 4 oxygens, these 2, and then those 2, so that gives me 4. And then over here I have 2, so if I put a 2 here, that gives me 4 for each of those. And then we can kind of check the others and see where we're at. We still have a 1-to-1 on the carbons, because I think that's going to do it for us there. So hydrogens, we still have, or it works out that we end up with 4 here. And if we look at our hydrogens here, 2 times 2 is 4. Voila, there we go, balanced chemical equation. Okay, let's look at another one here. I think I've got another one ready here. Aluminum, oxygen yields aluminum oxide. So I'm going to erase this. So I've got aluminum plus oxygen gas, O2, oxygen gas, yields aluminum oxide. And so I think that's Al2O3. Okay, so take a little room for how many we would have there. Okay, so now I'm going to get rid of this stuff here real quick. And really, all we're working with is just 2 elements here. So we have aluminum and we have oxygen. Okay, and okay, so if we look then, like where's the best strategy here? And again, you can look at this and you can see, okay, well, there's 3 oxygens here and there's only 2 here. So what if I put a 2 here? That would give me 6 oxygens. I could put a 3 here, and that matches up with the 6 over there. But that gives me 2 aluminum. So if I put a 2 here, it looks like we have a 2, 3, 2. So, but remember, we want to try to, before we go there in our head, let's go ahead and do the before. So we have a 1-to-1. No, we have a 1-to-2 here with the aluminum, and we have a 2-to-3 with the oxygen. But by putting a 2 over here, trying to even up our number of oxygens to 6, that means I could put a 3 here, which brings me to 6 oxygens. And then that means I have to put a 4. There's 4 aluminums here, so I have to put a 4 here. So now we can look at, there's 4 aluminums, 4 aluminums on the product side, and then there are 6 oxygens on each side. Okay, so I guess the idea here is that you want to make sure that you have a strategy. So some of these get a little bit complex. They're a challenge to you. My suggestion is try them. I do put keys on your modules, and so you can always throw in the flag and go look. But give yourself a chance to have success. It's very satisfying to have a challenge and then see it through to completion. So I